I present a method of multimode and multichannel universal receiver, which is organized by FFT and Programmable Multimode Demodulators. This is the outline of my presentation. In the recent IoT environment, a number of wireless sensors, are being inserted in various industrial scenes. Even in the home application, wireless sensors becomes popular. For such as energy management system or security monitoring, and so on. In many cases, different modulation types are using for wireless management system. In many cases, different modulation types are using for wireless transmission, depending on the application. For instance, digital modulation for data transmission. Analog modulation when the latency is very much important, in such as music instrument. Especially for the case of different modulation transmitters are being used. The same number of individual receivers are required to handle the different mode. Our proposal is to replace the number of receivers in different channel and different mode by one hardware. Here's an example of wireless transmission systems, which we have developed focusing on batteryless transmission. The electronic drum required nearly equal to zero latency transmission for the convenient play. Therefore, analog modulation is used. Tachometer used OOK to transmit the real-time rotation speed. As shown in the figure, individual receivers are required to receive the different mode and different channel signals. Once a universal receiver is available, which can handle multimode and multi-channel signals by single antenna and single hardware, the system becomes much simpler and contributes to save the space and cost. The next subject is universal wireless receiver scheme. Here's our proposal of universal receiver. It consists of an antenna, a mixer, an IF amplifier, an ADC, an FFT, followed by programmable and multimode demodulators. The multiple signals are received by an antenna and down converted to IF frequency. After required amplification, the signals are AD converted and then subjected to the FFT process. The multiple channel signals are divided into individual frequency elements corresponding to the channel sets of received wireless signals. Each signal is loaded to appropriate demodulator through a matrix switch, such as FM and FSK to discriminator, ASK to digitizer, and AM to output directory. Here's an example of combined two signals received through an antenna. A 1 MHz carrier is FSK modulated by digital pulse. and 2 MHz carrier as OO gate. The combined waveform becomes like this shape. The combined signal is subjected to FFT process. The frequency elements are separated into two parts, corresponding to the original 1 MHz and 2 MHz from moment to moment. You can see the frequency of 1 MHz part shift, while 2 MHz elements shows on and off. After the demodulation process, the original signals are obtained at the receiver output. The previous chart are 4 digital signals, and now an example of analog modulation is shown here. 1 MHz carrier is for AM, and 2 MHz for FM. The resulted combined signal is shown. The signal level changes corresponding to the analog signal for modulation in AM mode, while the frequency shift in FM modulation case. A discriminator which converts frequency shifts to amplitude is used to obtain the received signal in FM case. The FFT output itself is expected signal for FM mode, AM mode. The next subject is fabrication of multimode and multichannel receiver. And this is a block diagram of the receiver we developed for the experiment. A double super heterodyne architecture is used for the RF and IF section to obtain enough gain and sensitivity. The output of second IF is AD converted and then subjected to FFT implemented in FPGA. After frequency separation by FFT, Programmable Demodulators also implemented in the same FPGA. It's applied in accordance with the modulation types of received signals. The individual multiple output is obtained through the DAC. All of the functional blocks are placed on the small printed circuit board, measured by 67 by 70 millimeters. You can see RF section input here, LNA and 2 mixers, ADC, FPGA for FFT and Programmable Demodulators. Output DAC and related power regulators. The performance of receiver was evaluated by two ways. The total gain of analog section, organized by LNA, mixers and IF amplifiers was measured. When a signal of -90 dBm from a signal generator is applied to receiver input, 1 VPP could obtain at the second IF output, and which was enough signal level to drive ADC. It is said that the total gain of the system is 94 dB. Two signals, one is burst signal on 315 MHz simulating an OO gate, and another is 314.5 megahertz analog FM are applied to the receiver input to verify the basic operation of the multi-channel and multi-mode receiver. The repeated pulse and analog wave were obtained at the DAC output as expected. I will show the result of the experiment by using actual electronic drum and yo-yo application. Here are one electronic drum pad with batteryless transmitter and two yo-yos which also have transmitters, operated by the generated power from the embedded generators. The output waves from the receiver were monitored by oscilloscope. The figure shows receiver waveform from a drum in analog FM modulation and a yo-yo in OOK modulation. The drum output contains some steps because of limited resolution in digitized process. The waveform after applied a low-pass filter is shown in right-hand side, which shows enough signal quality for the electronic drum application. Note that the output will drove a synthesizer and obtain a proper drum sound successfully. In the yo-yo case, an analog discriminator was used to use the demodulation in this experiment. Therefore, some noise was seen along with the target digital OK signal. It was found that the digitization was necessary to obtain complete OK signal. The waveform after mathematically digitized signal is shown in right. A digitized process was added to the Demodulator in the FPGA code to obtain clear OK signal. The resulted receiving signals from two yo-yos are shown in the figure. Noise obtained in the previous testing was eliminated and clear pulse are received from two different channels. Through the series of experiments, it can be such that the FFT separates multiple frequency elements into individual parts, and the programmable demodulators creates original modulation wave for OK, AM, FSK, and FM. The next subject is conclusion. This is conclusion, and this concludes my presentation. Thank you very much for your time and consideration.